Good evening, ladies and gentlemen, and I would like to start our webinar about the newest camera which was developed by our company. And today we will talk about 61 megapixel camera, which can be easily installed on Matrix 200 or Matrix 300, and it provides amazing quality of the images, and it has changeable lens. And you can install here multispectral lens. Amazing multispectral lens from Agrovin company from Israel. And today, Ira from the founder and the founder of this company will explain us how to process multispectral data and what is the advantage of using 61 megapixel camera together with multispectral lenses. So we will wait several minutes while all our users will join us, and we will start our webinar. Ira, nice to meet you and nice to see you again. I hope today we will discuss with our clients how to use, how to expand their mapping, mapping services to agricultural services, forest inventory with using of your multispectral multispectral equipment.
Yep. So it's very nice being here with you guys, and I hope that we'll have knowledgeable people, joining the webinar, and I'll try to do my best to explain in a clearest way how simple actually it is to use the multispectral features of the camera, which tends to be a dual-purpose camera, because we take the camera in a panchromatic mode, and once you use our lenses, you can use it as a multispectral sensor. If you add a clip-in filter, IR cut filter, you can keep using it as an RGB camera, meaning this tends to be a very efficient solution in the sense that you don't need to have two cameras, one for a multispectral, one for RGB.
Super. Let me start my presentation about our cameras, which was developed recently, and and all these cameras were already used by our clients from several countries. Right now, several clients from Israel are using our cameras. One client from several clients from Romania, Ireland, and from US, and we receive a lot of feedbacks from them, and we improve our equipment right now. And today another one client from Israel, Roman from Aerialis company, will show us the comparison between 61 megapixel TOPODRONE camera and DJI P1 camera. And he made a lot of tests, and he made a lot of projects with both of cameras, and he will share his results as well. Romana, I can see that you already joined us, and nice to see you again. And I will start my presentation. So today we will try to make it in to arrange all our webinar within 1 hour or 1.5 hours. And if you have any questions, feel free to ask us any question. And during our presentations, we will explain you how to use high-resolution cameras for survey and mapping, how to expand your business for multispectral survey, and of course, Roman will share his experience, real experience, which was which has been recently received from the field. And let's go. And I will start my presentation. I will start sharing the screen. And if you have any questions, feel free to ask it in Q&A section or in the chat. Several years ago, when we made survey in Qatar for three-dimensional mapping, we faced one problem, that the working range, light range of DJI cameras was not enough, not efficient, and was not enough to make photogrammetric survey. Why? Because if we have a large quantity of sun, if we have very light conditions of survey, DJI cameras starts to be a little bit noisy, and this noise influences to the quality of data sets and to the quality of orthophoto. And we spent more than 1 week to find out a solution. What shall we do? And after that, we understood that we can use special filters to remove some part of the light from which was reflected from roofs and from metal parts. And after that, photogrammetry starts to work. But and this was the first point when we decided to develop our own solution for photogrammetry and for surveying mapping. And after that, we created solution when we use Sony RX1 camera, which was integrated with a gimbal, and it is possible to install on the Matrix 200 or Matrix 300. Why we decided to use Sony cameras? Because Sony cameras have a wider range, wider working range, especially in terms of they provide less noise, and they can operate in wider settings. For example, you can set up wider ISO, aperture, or shutter speed. And these cameras overcome some problems with the DJI camera when you have borders, when you have borders with the shutter speed, for example, up to 2000, for example, or when you have some problems with ISO, with high level of ISO, when images become noisy. And after this, and we have got very good experience with Sony cameras, and after that we decided that we need to make a deeper integration. We need to develop a deeper integration inside of DJI flying systems like Matrix 300 or Matrix 200, and to make our solutions more easy to use and provide more usability. And finally, this year we designed and we produced two cameras, 61 megapixel camera and 24 megapixel camera, which can be easily installed on Matrix 300 or Matrix 200 version 2. And these cameras expand borders of using of cameras and photogrammetry survey, providing better resolution, providing better quality of the images. Or you can use our 24 megapixel camera, which can be installed on Matrix 200 or Matrix 300, and which has less price in comparison with P1. And our camera was designed to use it on a 3-axis gimbal like this one, or you can install the same camera without the gimbal on our lidar system. And in this case, you will make survey. You will colorize point cloud immediately from the camera with using of our lidar system. And as I already said, we have two different sensors: 61 megapixel full frame sensor Sony sensor for 61 megapixel, and 24 megapixel camera sensor from Sony as well. And the main advantage of our system that our cameras are compatible with any type of lens. You can use 60 millimeters with lens, 18, 24, 35, 50, even multispectral lens. And we found out a very good solution for multispectral survey from Agrovin company, which provides a wide range of lenses with a different number of multispectral channels, which provides a high resolution data. For example, 10 channels multispectral lens provides 15 megapixel resolution of the images. It's amazing, outstanding quality of the multispectral data, even with a very good resolution. And the next step of our development was to design the system which will have a deep integration inside of DJI. So right now you can plan mission with using of DJI Pilot application, with using of UGCS application. You will get live video, and you can change the settings of the camera. Aperture, ISO, shutter speed can be easily changeable during the flight from DJI application. And the 61 megapixel camera provides a full deep integration inside of DJI, and provides all possibilities for settings, for video transmission, and it's the most powerful our solution right now. And 24 megapixel camera provides possibility to plan the mission, to trigger the camera, to see video on your screen from DJI or UGCS application, but it is not possible to change settings of the camera. You need to set up the camera before the flight. There are special buttons here where you can set up the camera, for example, shutter priority, and after that camera, because of the wide working range of the light sensor, camera will work automatically, and camera will provide the best quality of the images because of the Sony sensor. And once again, I would like to draw your attention that you can see live video on your screen, and even from multispectral camera. I don't know, Ira, if it is possible to see multispectral feedback from microsense camera or any other type of multispectral cameras. Do you know?
As far as I know, you cannot see the multispectral.
Yeah, and this one, it's a great advantage right now. So you can fly on a low speed, low altitude, for example, and you can see on the screen the right position of your camera, and you can capture a photo of a of the certain part of your object for multispectral survey. If you fly on low altitude, but if you fly with high altitude for mapping, in this case, you can evaluate the quality of multispectral data. You can evaluate shadows, you can evaluate sun conditions, light conditions. So it's a great advantage. And you can trigger the camera, and you can set up all settings of the camera online during the flight. It's a great advantage, really. I never met it before. So, and of course, you can use the same camera with multispectral lens or with original RGB lens from Sony, and you will get, so you can provide, you can get images for your photogrammetry survey, for mapping, or you can make survey with multispectral lens to get multispectral data for monitoring, evaluation of forest and so on. So, and it's a great flexibility. What you need just to remove the lens and install a new one. So it's a great advantage as well. And of course, it is 61 megapixel camera, which is not there is no any other solution like this one right now on the market. And as you know, TOPODRONE company provides solution for first of all, TOPODRONE company work with the surveyors and provides solution for high precision mapping with the drones. So all our solutions, all our cameras use PPK system. Even you can process multispectral data in PPK mode, and you will georeference your multispectral data with centimeter level accuracy. Right now, we tested 10 channel multispectral lens, and we achieved 2 centimeter accuracy of multispectral data from 100 meters altitude. I can show this result. It's amazing. I never saw it before from other multispectral solution. Why? Because you have real PPK system inside of our system. You have software to post-process data. And the quality of the lenses, of multispectral lenses, provides a low level of distortion and high resolution. As a result, the data set which can be derived from this camera. It has a huge advantages in accuracy. Okay, as soon as you make survey with the camera and you can evaluate the quality of your survey looking on the screen in real time. After that, you need to download images, you need to download UBX files from the drone, you need to download datasets from your base station, make all necessary changes, and after that you can post-process data, and you will get precise trajectory of your flight. And software will create will georeference images, and after that you can upload these images immediately inside of Agisoft or Pixabay software or 3D survey. And right now I would like to show you the first project which we made with our camera. It's a project of large area survey, and we made survey with a 18mm lens with a 61 megapixel camera from 100 meters altitude, and we covered 1.4 square kilometers. It's amazing result. Just one flight, and you will cover more than 1 square kilometer of high precision and high resolution data sets. After post-processing, what you need just to upload all images inside of Agisoft, for example, start air triangulation, and you in automatic mode, you will get high precision, you will get a high accuracy, and your error will be between 2 and 5 centimeters, depends on the flight speed and flight altitude. Of course, if you fly in low altitude, you will get accuracy approximately within 1 and 2 centimeters. But when you fly on 100 meters altitude or on 150 meters altitude, in this case, you will get accuracy between 3 and 5 centimeters without using any ground control points. And this project, we will publish this project on our website, and you can download data and you can evaluate data sets by yourself. And what another advantage? Everybody knows that in Europe we have a restriction to fly lower than 120 meters altitude. And if we use P1 camera with 35 millimeters lens, we will get small coverage on the ground. But with our solution, you can fly with 18mm lens with 61 megapixel camera, and you will get coverage of the images approximately 30% more or 50%. So in this case, you will cover a large area from 120 meters altitude without rising higher restricted area, and you can achieve and your survey will be very efficient. And this one example is just we calculated the area of our survey, and as you can see, I didn't draw all area, but if I make a drawing of the whole area, we can understand that we will cover 1.4 square kilometers per one flight. And the quality of the data allows us to vectorize power lines, to vectorize power wires, power poles, roads, buildings, everything what you need, even small light poles. And on this example, you can evaluate that from 120 meters altitude, you will get very accurate and very detailed point cloud. And this point cloud looks like we fly on 60 meters altitude with a Phantom 4 Pro RTK, for example. And if we fly on 60 meters altitude, we can capture road signs. This one is a good example where we made a photo of our drone close to the bridge, and on the point cloud, I found out the same road signs and the same structure of the bridge. So everything was reconstructed with high details and with high precision. And of course, you even from 60 meters altitude with our camera, you will get a large coverage and high resolution data as well. And next our project, we made survey with the multispectral lens. We installed it on 61 megapixel camera as well. During survey, we can watch real video feedback, and we can evaluate the quality of our survey. After that, we download all images, and it's a little bit strange to see how it's organized. So right now we can see that all our photos are divided to 4 parts. Inside of these 4 parts, we have 3 channels inside, or 1 channel inside, depends on the parts. And the result for 61 megapixel camera with quadr lens, we will get 10 multispectral channels. And we can make GNSS data post-processing. We can identify precise position of the images with using of our PPK system. And what we need to do is just to upload images, to copy images to one folder, select UBX file from GNSS receiver. After that, select offset of the antenna, which is already predefined in our TOPODRONE post-processing software. After that, we need to upload a base station. On the map, we can see start point of our flight, and we can see position of the base station. After that, you can read the number of photo events. You can read in the log section, you can read number of photo events. You can read the number of photos. And after that, after post-processing, we will get position of the images with the red color. It means that we have a fixed solution. We have high precision images. Inside of our images, we will have high precision coordinates with accuracy between 1 and 3 centimeters. And after that, all these images, all these multispectral images will be georeferenced with high precision coordinates inside. And after that, we need to use AgroWing software to divide these images to separate channels. And it can be done totally automatically. I already tested it several times. It's amazing productivity. It's very easy just to upload this image. And after that, software can automatically divide on 4 parts and can automatically merge all together. And after that, you can extract even single bands, or you can extract, you can compose all your bands inside of one image. And as soon as we already georeferenced images, after processing, after multispectral data processing, you will get a set of small images in a separate multispectral channels with high precision coordinates inside of EXIF text. So after that, what you need is just to upload these images to Adjustop, start button for air triangulation, align blocks, and you will get high precision results with high accuracy. And as you can see here on this screenshot, we check with block of images with using of our base station, and the position of the base station was recognized on the images with accuracy between 1 and 2 centimeters. It's amazing result, and why we achieve such high quality of precision. Why? Because inside of this multispectral camera, we have very well calibrated lenses with a low level of distortion. It's very important. And for photogrammetry, it's very important. And finally, as soon as you process this data, after that, you can create multispectral orthophoto, you can create mosaic of the images, and you can combine multispectral data together with RGB data. And all this data will be georeferenced together, and you don't need to use any ground control points to georeference this data like this one, like right now you can see on the screen. And we achieved very amazing, outstanding results in matching between RGB data, which was collected by 61 megapixel camera with a resolution of less than 1 centimeter, And after that, we combine it with multispectral data with resolution of several centimeters, and all data sets were aligned together perfectly. And after that, it's another one task is to process multispectral data, to recognize spatial structure, and I think Ira will describe it better. And finally, what I would like to show you, that TOPODRONE 61 megapixel camera provides a better resolution, provides huge, bigger coverage because of the using of separate, because of the using of different kind of lens. And as a result, you can fly inside of the permission area, but with but more efficient, and you will get accurate results because of the PPK system, TOPODRONE PPK system, which is installed inside. So thank you for your attention. And Ira, could you, if we have any question, I will answer. And if we don't have any question, Ira will continue my presentation.